Nice! Let's get this started with Illustrated Dictionary of Physics. And next, let's go! Now, in our last episode, we talked about heat and all those kind of things. Now, we're going to be talking about waves and electricity and magnetism. Let's get this started with! So, waves are one of the most important things about physics. In fact, without waves, you wouldn't even be able to watch this video. More or less hear it. You can't even hear it at all, too. And then later, you'd even need to use special things to actually be able to hear it. Without waves, nothing in that screen and no sound on that screen would actually be able to work. In fact, reflection, refraction, and diffraction, all those things are one of the most important things about this whole wave thing. In fact, reflection is just waves bouncing back towards you. And incident waves are just when there are two waves and then they meet together. And without waves, you wouldn't be able to do this. Or, more interestingly, this. Come on. Yes. Whee! That's pretty cool, isn't it? And of course, there are different types of waves. Now, here are the electromagnetic waves. Now, most of them is light. In fact, this visible part here is visible light. However, it's not light. The one to see light is definitely a wave. In fact, it's more or less somewhere in between a particle and a wave. When I draw out light, like in dimensions of particles and waves, I actually think of it like this. A dot traveling in a wave. And so it's drawing a wave as it goes. And of course, the shorter the wavelength, the more energy it is, and the shortest wavelength has the most energy, which is why quantum physics, we have the Heisenberg uncertainty principle, where we have no idea what happens, what small things happen, because visible light waves cannot hit those small particles, as they'll just go over them. So yeah, just do the small ones, and they'll just make that move, so we can't know it for certain. And yeah. Next thing we can do, this is my favorite wave, microwaves, because it's the waves that cook, and I love the cook stuff. And then we have infrared radiation, which is the things that let us see heat. It's the waves that use to see heat. And then we have ultraviolet radiation, not that harmful to us, and it's UV light basically, and it's used for banknotes. Visible light, the kind that we see. And then we have, ultraviolet radiation is right here, I accidentally skipped it. And then we have X-rays, all of these are X-rays, including gamma rays. Oh wait, I'm covering it up. And the green part is gamma rays, the kind that turns you into the Hulk or Spider-Man. And you're like, yeah, I am Hulk smash, ah! Yeah, I'm a maniac. And those are electromagnetic waves. Light is just those stuff that lets you see stuff, which is the reason why you can see this random YouTube video. And light can also be reflected. Of course, it goes at an angle. If you do it like this at 90 degrees, it goes back at you literally. And if you hit it at a 30-degree angle, it'll go and hit, and it'll bounce off at a 120-degree angle of where you hit it. You know, that's a nice idea. And refraction of light. Light is refracted because of how it interacts with other things. Claude? Oh, he didn't say anything. And so here we are, Claude. Here, yeah. Come here, little boy. Come here. Yeah. And so while I'm here, let me just explain to you about refraction of light. Light needs to go in a straight line, unless it's like reflected or something. And with that, you basically have to go through something. Like if you go through glass, sometimes it doesn't look that clear. That's because of refraction. And in water, it's like if you put a pencil in a glass of water, the pencil looks like it's split in half and one part's on the other side and one part's on this side. That's because the water reflects the light a little bit in the water part, so that it looks like everything's moved a little bit to the left or a little bit to the right. And then we have temperature. And temperature is just how hot something is. It's very different from heat, though. Remember that heat is the energy that makes temperature, and temperature is just a measurement of the heat. And then we have to talk, and yeah. Well, we've already talked all about this. Let's just skip all that. Now we're on to static electricity. Static electricity. Static electricity. Static electricity is a great thing because it's it's basically the electricity that we use to make balloons stick to your head or make air pollution stop. Please don't go. Like, this is actually way better. Well, he scratched me several times, so away he goes. And this is also how you use magnets. Electromagnetism is basically what you use to be able to make magnets. In fact, the batteries basically can make electricity. And so if a battery can make electricity, then and magnets can make electricity, then technically electricity can make magnets, right? Yes. The electric current can make a magnet. And so you can control the current, and then if you and then you can like make batteries out of it. You can. Lots of people used to use liquids for their batteries, but nowadays we use paste with the same chemicals inside, so it's portable. Also, it's not as efficient and it's not permanent. It needs a recharge though, which is bad. And then we have magnets. You can literally create an electric current to make a magnet. Magnets always have a magnetic field around them, which makes them have a North Pole and a South Pole. And the North Pole always is attracted to South Pole, and South Pole is very attracted to North Pole. South Pole is repelled from South Pole. North Pole is repelled from North Pole. Yeah. And electromagnetism is basically where you do this. One thing is where you basically coil a wire on a metal that could be magnetic. It's just not in a magnetic way, and with that the electricity coils around it and it makes a magnet, and with that you basically created yourself a little electromagnet. And somehow the second coming in Alan Metcalfe was able to twist a piece of metal that is longer, that is thicker than his own limbs, around a rocket, and he used that to make a magnet. How freaking ridiculous is that? And you can even use that electromagnet to be able to create a current because it's an electromagnet. The magnet can literally create the electricity, and vice versa. And that's pretty much. And the last thing I'm going to have to talk about is cathode rays. Cathode rays is a continuous stream of electrons, which are, thank you for meowing, negatively charged particles, and they're traveling through a low pressure gas or a vacuum. And it's literally produced when electrons are freed from a metal cathode and attached to an anode. And an anode, oh my gosh. And an anode is basically where you use the positively charged protons. And with a cathode and anodes, you can literally create a little battery. And then with that, you can make a TV screen, or the old TV screens. Nowadays, we just use LCDs. So, until next time, folks. See you soon, and keep having fun with light waves. Where's... there we go.